morning to everyone. I am Nerele Srinivas. In this class, I am going to explain you the plane from coordinate geometry. The plane see definition of the plane. Plane is a flat surface which can be extended infinitely in all directions. Suppose if you treat this board as a plane, so it has four edges. So now you can extend in these four directions. Got the definition of a plane? The simple way you can define the plane like this. A surface is called a plane. Okay? On this plane, we people can able to put infinitely many points. Am I right? See here. See. Like this you can put infinitely many points. If you connect these points, you get a line segments like this. If you extend this line segment either side, you get a line. So on the plane, we people can able to draw infinitely many lines. That lines may be parallel to each other. That lines may be coincident. That lines may be concurrent. Like you can draw many more lines on this plane. See, this is a plane and this is space. On this space, I am considering a point P through which you can draw many more lines. You know, in the two-dimensional or 2D coordinate geometry. Okay, so there we have drawn infinitely many lines through the point. Like this, through the point which belongs to the space, you can draw many more lines, but among all that, only one can be perpendicular to this plane. Here this is space and this is plane. Now there is a one point. Through that point, how many perpendicular lines can be drawn to this plane? Only one. Okay, remember this point. Actually through that point you can draw infinitely many lines, but among all that, one can be perpendicular to the plane. That is said to be normal to the plane. What it is? Normal or normal line. So as I said to you, on the plane you can draw infinitely many lines. So for all those lines, so this normal is perpendicular. Okay students, remember this. Now let us go to the standard form of a plane equation. See here, ax plus by plus cz plus d is equal to 0. This is the general equation of a plane where this a comma b comma c comma d belongs to real numbers and simultaneously a, b, c should not be equal to 0, which means that a square plus b square plus c square should not be equal to 0. This is the condition. All at a time should not be equal to 0. A can be 0, b can be 0, c can be 0. AB can be 0, BC can be 0, AC can be 0. But at a time, A, B, C should not be equal to 0. Okay? So, right. Where A, B, C, D belongs to real numbers and A square plus B square plus C square should not be equal to 0. And A, B, C are the DRs of the normal. What is normal? You got it. where this ABC are there, no? So which are DRs of whose normal? DRs of normal. See, suppose if D is equal to 0, if D is equal to 0, then it passes through the origin. If D is equal to 0, then this plane equation will become AX plus BY plus CZ, which is equal to 0. So this passes through the origin. Right? See, suppose if you would like to find x-intercept made by the plane, so then what do? Put y0, z0. See here, ax plus by plus cz plus d equal to 0. If you would like to find x-intercept made by the plane, so just put y0, z0. So that you will get ax plus d equal to 0, then x will be minus d by a. In the same manner, y-intercept made by the plane, then what do? Put x0, z0, so that you will get y equal to minus d by b. Suppose if you want z-intercept made by the plane, so what you have to do? For which you have to put x0, y0, so that you will get z is equal to minus d by a units. Units you have to say, because intercept means that is some distance from origin to the plane. So these are the intercepts made by the plane. This is x-intercept, y-intercept, z-intercept. Next, see students, find the equation of a plane which passes through a comma 0 comma 0. This is x-axis, this is y, this is z. See, 0 comma b comma 0, 0 comma 0 comma c. What are given? X-intercept of the plane, y-intercept of the plane. This is x-intercept and this is y-intercept and this is z-intercept. A, B, C are the intercepts made by the plane. Then find the equation of this plane. So you get like this: x by a plus y by b plus z by c is equal to 1. On the plane, if three non-collinear points are given, through that three non-collinear points, we can draw only one plane. That is also can be called as a triangular plane. If three non-collinear points on the plane are given, through which how many planes can be drawn? Only one plane. And suppose two parallel lines are given, through which also you can draw only one plane. See here, whenever the x-intercept, y-intercept, z-intercept of the plane is given, so in such case you would have to apply this formula: x by a plus y by b plus z by c equal to 1 is the equation of that plane. You can also call it as triangular plane. See, suppose only one point, and see here, whenever one point and a normal of the DRs of normal of the plane are given, then find the equation of the plane. Find the equation of the plane which passes through a point x1, y1, z1 and having DRs of whose normals a comma b comma c. This is plane. Otherwise, take a plane like this. On the plane, one fixed point is given whose coordinates are x1 comma y1 comma z1 and whose normal, this is the normal. Okay, actually normal will be like this, but this is a 2D board, but we are discussing 3D geometry. Hence, you cannot able to draw Okay, normal like this, just consider this as a normal. Okay, students. So, meaning of a normal. Normal means a perpendicular line to the plane whose DRs are given. A comma B comma C are the DRs of this normal to this plane, and one of the fixed point is given. Now, what they are asking? To find the equation of this plane. Then what you people have to do? Take any locus point on the plane. Locus point, let it be P, X comma Y comma Z. Okay, if you connect this PA, you get a line segment which belongs to this plane. Then our this line and this line mutually perpendicular. Okay, students. So, in the 3D geometry, you learned there. So, if DRs of this line and DRs of this line are given, if the two lines are mutually perpendicular, then you read A1 A2 plus B1 B2 plus C1 C2, which is equal to 0. Where A1 B1 C1 are DRs of one line, A2 B2 C2 are the DRs of other line. Whenever the DRs of two lines are given, if the two lines are mutually perpendicular, and this is the condition which you learnt in the 3D geometry. See, students, so here normal DRs are given in the problem and 2 points on the line are given. So now find the DRs of AP. DRs of AP. So X minus X1 comma Y minus Y1 comma Z minus Z1. Okay, students. See, you got the DRs of AP and DRs of normal. So both are perpendicular. Hence, apply this formula. So here A into X minus X1. A into X minus X1. B into Y minus Y1 plus C into Z minus Z1, which is equal to 0. So this is the equation of a plane when one point on the plane and whose normal DRs are given. Remember this. A of X minus X1 plus B of Y minus Y1 plus C of Z minus Z1, which is equal to 0. Right. Next, suppose 3 points on the plane are given. How do you find such a plane equation? 3 points on the plane are given. This is a plane on which 3 points are given. A, X1 comma Y1 comma Z1. B, X2 comma Y2 comma Z2. And C, X3 comma Y3 comma Z3. X3 comma Y3 comma Z3. If 3 points are given on the plane, and find this plane equation. So whenever the 3 points on the plane are given, so use this formula to find equation of that plane. X minus X1, X2 minus X1, X3 minus X1, Y minus Y1, Y2 minus Y1, Y3 minus Y1, Z minus Z1, Z2 minus Z1, Z3 minus Z1, which is equal to 0. Find the determinant which forms by this X minus X1, X2 minus X1, X3 minus X1 in the first column. In the second column, Y minus Y1, Y2 minus Y1, Y3 minus Y1, Z minus Z1, Z2 minus Z1, Z3 minus Z1. Okay, students, very easy actually this is. So whenever one point and whose normal DRs are given, I said to you to find equation of that plane. A of X minus X1 plus B of Y minus Y1, C of Z minus Z1. See, This is the equation of this plane. So on this plane, these 2 points are also lying. Hence replace this x, y, z by once this second point and once this third point. You can generate 3 equations. After that, find the determinant which forms by whose coefficients. Like this we will get, and go for simplification. You know how to find the determinant of 3 by 3 matrix, so that you will get one equation. Okay students, just remember like a standard formula. What is this? Equation of a plane which passes through these 3 points. Very easy to remember, no? See, x minus x1, y minus y1, z minus z1. Come to the second row. x2 minus x1, y2 minus y1, z2 minus z1. Come to the third row. x3 minus x1, y3 minus y1, z3 minus z1, which is equal to 0. Right. Next, suppose 4 points are given. Suppose 4 points are given, and sometimes 4 points will be given to you, and they will ask you to check whether these 4 points are coplanar or not. Coplanar or not. How do you check? Tell me students. What are meant by coplanar? The points which belongs to the same plane are known as coplanar points. See, A, x1 comma y1 comma z1, B, x2 comma y2 comma z2, C, x3 comma y3 comma z3, D, x4 comma y4 comma z4. 4 points on the plane are given, and they are asking us to check whether those are coplanar or not. See, very easy students. See here. Here also, whether these are coplanar or not, how do you check means you have to follow that 3 by 3 data only. So you have to, okay, whenever these 4 points are coplanar, compulsory you will get x4 minus x1, x3 minus x1, here you have tried, and x2 minus x1. Now, in the same manner, in the second column, y4 minus y1, y4 minus y1, and here y3 minus y1, y2 minus y1. Here z4 minus z1, and z3 minus z1, z2 minus z1, which is equal to 0. So the determinant which forms by this which is equal to 0. When do you get the determinant is equal to 0? Whenever these 4 points are coplanar. Okay students? Right. Next, let us go to the projection of a point on x-axis, y-axis, z-axis. One point A will be given to you. x1 comma y1 comma z1. And they will question us to find the projection of this point on the xy plane or x-axis. Projection, which is nothing but put. Okay, see, it is there on the space. So, and they are asking us to find whose projection on x-axis. This is origin, x-axis, y-axis, z-axis. This is a point on the space, and we need to find whose projection on x-axis. Same like in the 2D you learned. So here a point is given whose coordinates are x1 comma y1. So what is the projection of this point on x-axis means here this put you would have to find. What are the coordinates of this point? x1 comma 0, because this point belongs to x-axis, so that where y value 0. In the same manner, the projection of this point on the x-axis means somewhere you may get here as x1 comma 0 comma 0. The projection of this point on y-axis 0 comma y1 comma 0. The projection of this point on z axis 0 comma 0 comma z1. What are these students? Projection of this point on x axis, y axis, z axis. Projection, which is nothing but put. You know, in the straight lines you learned the meaning of put. Right? Suppose two points are given. See, A coordinates x1, y1, z1, and B x2, y2, z2. If you connect these 2 points on the space, you get a line segment. I want whose projection on x-axis? Projection, which is nothing but put. But if it is line, then you need to find whose shadow on x-axis. So suppose, see here, you may get here. Students, this is origin, x-axis, y-axis, z-axis. Now, whose projection we may get here like M, x1 comma 0 comma 0, and find whose projection on x-axis. Let it be N. Now, x2 comma 0 comma 0. Now, what is the projection of this line on x-axis means whose projections we have calculated. Now, measure the distance between M and N so that you will get the distance from M to N is mod of x2 minus x1 units. Let it be some P. In the same manner, find whose projection on y-axis. Let it be Q. How much do you get, students? y2 minus y1 units. Units here you have to write because distance, you know, in the coordinate plane, if you measure distance between any 2 points, you would have to write units. If you compute area, you would have to write square units. You know that. Now find the projection of this on z-axis. Let it be R. Mod of z2 minus z1 units. Okay, students? Right? Now, okay. Now, measure this p square plus q square plus r square. What do you get, students? P square plus q square plus r square. Tell me. See here, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. See, what is this? Distance between, square of the distance between these two, AB square. Now, P square plus Q square plus R square. So, suppose if you want AB, then transfer square to the right side. Square root of P square plus Q square plus R square. Remember that. Okay, students? I hope you have understood this. Projection of AB on x-axis, this much you got. We have taken that as Q. So in the same manner, projection of this AB on y-axis, this much you will get. On z-axis, this much you will get. Take the square on both sides and add it. So you will get this one. What is this? Square of the distance from A to B, no? AB square. Transfer square to the left side so that you will get square root. Okay? Right. Next. See, suppose if you want projection of this AB on XY plane. On XY plane. The plane which passes through x-axis and y-axis is known as XY plane. Okay. So, projection of a point on XY plane. Suppose, how do you find? This point is given x, y, z. What is the projection of this point on XY plane? XY plane means which passes through x-axis and y-axis. Whose projection on x-axis is, XY plane is xy comma 0. The projection of this point on yz plane which passes through y-axis and z-axis. Okay, in the 3D system. So, what is the projection of this point on yz plane means? On the yz plane, x value will become 0. The projection of this point on zx plane. So, zx plane which passes through z-axis and x-axis, where y value will become 0. You know this. Okay, what are this? The projection of this point on xy coordinate plane. On xy plane. What is this? Projection of this point on yz plane. Projection of this point on zx plane. So, now I am going to explain you projection of a line segment AB on xy plane. On xy plane, A coordinates x1 comma y1 comma z1, B coordinates x2 comma y2 comma z2. Now I want the projection of AB on xy plane. So remember, like a standard result, students, projection of AB on xy plane. Projection of AB on xy plane, which is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Units. Because length no units. This is the projection of AB on xy plane. Now projection of this AB on yz plane. Let us take this projection of AB and xy plane. This much you got, no? Let us name this one with a small a. So now find the projection of AB on yz plane. Let it be B. On the yz plane means, so here on the xy plane means here difference of z coordinates did not come, no? So if you find the projection of AB on yz plane, so here x2 minus x1 will not come. Just you get y2 minus y1 whole square plus z2 minus z1 whole square. What is this? Projection of AB on yz plane. On yz plane. On yz plane. On zx plane. On zx plane. Root of students, x2 minus x1 whole square plus y2 minus y1 whole square units. Now students, I am asking you to find sum of the squares of this ABC. A square plus B square plus C square. How much do you get? See here. This comes 2 times, this comes 2 times, this comes 2 times. Okay? See on zx plane, zx means here z2 minus z1 will come. Z2 minus z1. Now take the square on both sides and add it so that you will get 2 into bracket of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That is nothing but square of AB. Now A square plus B square plus C square, which is equal to 2 into AB square. Okay? Right. Based on this, you expect some applications while doing the problems. Right, students? Next. Here there is a one line whose coordinates are here. One end of the line coordinates are x1 y1 z1 and other end coordinates x2, y2, z2. Now I want, see, what is given here? The projection of AB is this one. Let it be MN, whose DCs are given L, M, N. What are these? DCs of MN. What is MN? Projection of AB. Like shadow. What it is? Shadow of this AB is MN, whose DCs are given and whose endpoints of line are given, and they are asking us to find length of projection of AB on MN. Okay, length of projection of AB is mod of L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1 units. Okay, students, what is this? Length of projection of AB on a line, that is m. If you can extend this line on either side, but that projection part of AB on this line be MN, whose DCs are given. L, M, N are the DCs of this line, and one line segment is given. Okay, now what is this? Length of projection of AB on this line, where L, M, N represents DCs of this line. Sometimes they don't give you DCs, they will give you DRs like ABC. Whenever the DRs are given, how to find DCs you know. Get the DCs and apply the same formula. What are given, Amma? DRs of the line. So when DRs are given, how to find DCs? So these are DRs of the line. Now DCs formula you know, plus or minus A by root A square plus B square plus C square, comma B by root A square plus B square plus C square, comma C by root A square plus B square plus C square. So when the DRs are given, like this you have to find DCs, let it be LMN and substitute in this. Sometimes instead of DCs, DRs will be given. In such case, prepare the DCs and substitute here so that you will get length of projection of this AB. Okay, right. Right, students. Next, you know, AX plus BY plus CZ plus D, which is equal to 0, represents a plane, and AX plus BY plus CZ plus K, which is equal to 0. Both planes are parallel to each other. Whenever the two planes are parallel, then you get the difference in the constant places. This part would be same. Okay, see, suppose here A1x plus B1y plus C1z plus D equal to 0, D1. A2x plus B2y plus C2z plus D2 equal to 0. If both planes are parallel, then you get this condition. A1 by A2 is equal to B1 by B2, which is equal to C1 by C2. Means whose normal DRs are proportional. A1 by A2, which is equal to B1 by B2, which is equal to C1 by C2. Which means that what are A1, B1, C1? DRs of whose normal? A2, B2, C2 are DRs of this normal. Both will be proportional whenever the two lines are parallel. If both lines represents the same plane, if both represents the same plane, both equations represents same plane. Same plane means here you get d1 by d2. Both will be coincident. Okay, students? Right. Next, sometimes, see here, they will ask you to find normal form of a plane. Actually, you know, in the straight lines also you read how to find normal form of a straight line. So here also, see here, there is a one plane, so which may be passes through here. Let it be OX, OY, OZ. Now this plane which is moving P units away from origin and whose DCs will be given. What are LMN? LMN are the DCs of normal to this plane. So here we have drawn a perpendicular from origin to this plane. Let it be OP. OP is the perpendicular distance from origin to the plane, whose normal DCs are given. This is a plane whose normal DCs are LMN. Then see here, LX plus MY plus NZ, which is equal to P, is the normal form of a plane. What is P? Perpendicular distance. Like let it be this length, small p. The distance from O to, let us take this point as you take it as A. A belongs to the plane, O is origin. OA is perpendicular to the plane, that is normal. Normal DCs are given. And here, LX plus MY plus NZ, which is equal to P. So what it is? Normal form of the plane, where P is the perpendicular distance from plane to the origin. Okay, students? Right. See, sometimes here AX plus BY plus CZ plus D equal to 0. Plane equation will be given like this, and they will ask you to convert this plane from this standard form into the normal form. So however you did in the straight lines, in the same manner you would have to follow that procedure only. So there, what did you do? This constant you have to transfer to the right side, and you have to make this RHS part would be positive. Already here, if it is negative quantity, if you transfer to the right side, you will get positive. If it is positive, right side, negative will come. Whenever if you get here negative, it has to be done as positive. How? By multiplying both sides with minus. Here I don't know whether it is positive or not. That depends on D. If D is negative, this will become positive. If D is positive, positive into negative, negative. If it is negative, multiply both sides with minus so that you can make RHS positive. So hereafter, divide both sides with A square plus B square plus C square and A square plus B square plus C square. Now divide this denominator to these three terms separately. So if you express the plane equation like this, that will be called normal form of the plane. So here RHS of this equal, whichever quantity is there, that will be the perpendicular distance from origin to the plane. Okay, students, this is called normal form of a plane. See, find the perpendicular distance from a given point to the plane. Same procedure. So whichever formula you applied in the straight lines, same formula here you have to apply. See here, plane is given, one point in the space is given, whose coordinates are P, x1 comma y1 comma z1. So here plane equation is ax plus by plus cz plus d equal to 0. Now get the perpendicular distance from this point to the plane. So which formula do you apply? Perpendicular distance. Perpendicular distance from that given point to the plane, which is equal to mod of, so here x coefficient ax1 plus by1 plus cz1 plus d by root a square plus b square plus c square. Okay, right here units. Just keep the modulus symbol for the numerator because anyhow denominator will be positive. Units right here. So this is the perpendicular distance from P to this plane. Remember, like a standard result. Mod of ax1 plus by1 plus cz1 plus d by root a square plus b square plus c square. So suppose if it is origin. If it is origin. Now replace x1, y1, z1 by 0, 0, 0 so that you will get mod d by root a square plus b square plus c square units. This is the perpendicular distance from origin to this plane. Okay, students? Right. Next, let us find angle between the two planes. How do you find angle between the two planes? See, same like our walls of the room. So this walls looks like a surfaces, planes. So whenever wherever those two planes are intersecting, there we get a line. Okay, students. So angle between that corners of the surfaces is known as angle between the planes. So here, students, here you get one question. Find the angle between the two planes. Two plane equations will be given to you like this: a1x plus b1y plus c1z plus d1 equal to 0 and a2x plus b2y plus c2z plus d2 which is equal to 0. Okay, angle between the normals. Here this has one normal whose DRs are a1, b1, c1 and this has one normal whose DRs are a2, b2, c2. Find the angle between the normals of these two planes. Angle between the normals of these two planes is equal to the angle between the planes. Remember like that. So you know cos theta, which you read in the DCC DRs. Okay, a1, a2 plus b1, b2 plus c1, c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Apply this formula so that you will get angle between the planes. How do you find the angle between the planes? Simply you would have to find the angle between the normals of both planes. The angle between the normals is equal to the angle between the planes. So suppose if theta is 90 degrees, cos 90, 0. Okay, if it becomes 0, take the cross multiplication. 0 into something, 0. Therefore, mod of a1 a2 plus b1 b2 plus c1 c2 which is equal to 0. So this is the condition for these two lines if those two are perpendicular. Condition for perpendicular planes. Okay, students, have we got this? Just replace theta by 90 and cross multiply so that you will get this condition. Right? Next, see, sometimes two parallel plane equations will be given to you and they will question you to find distance between the parallel planes. See here, ax plus by plus cz plus d1 equal to 0 is equation of one plane, and ax plus by plus cz plus d2 equal to 0. This is equation of other plane. Same like our walls of our opposite walls of our room. Now measure the distance between them. Okay, distance between parallel planes. Distance between parallel planes, which is equal to mod of d2 minus d1 or d1 minus d2. d2 minus d1 whole by root a square plus b square plus c square units. Okay students, apply this formula so that you will get distance between the parallel planes. Okay students, I hope you have understood this, and still 3 or 4 points are left. Okay, I explain you those 2 points. See students, you know what is the equation of xy plane? Equation of xy plane. On the xy plane, a z value becomes 0, no? So equation of xy plane. Equation of xy plane is z is equal to 0. In the same manner, equation of yz plane, x is equal to 0. Equation of zx plane, y equal to 0. You know xy plane which passes through x-axis and y-axis, now whose equation is z equal to 0. yz plane equation x equal to 0. zx plane equation y equal to 0. And now I am asking you to find equation of a plane which is parallel to xy plane and passing through a point x1 comma y1 comma z1. Find the equation of a plane which is parallel to xy plane and passes through a point x1 comma y1 comma z1 is z is equal to z1. What is this? It is a one plane equation which is passes through a point x1 comma y1 comma z1 and parallel to xy plane. In the same manner, equation of a plane passes through x1 y1 z1 and parallel to yz plane. Parallel to yz plane means x equal to x1. And find the equation of a plane passes through zx plane and parallel to zx plane and passes through x1 y1 z1 is y equal to y1. Okay, right? And see, you know how to find put of the perpendicular in the straight lines, and also how to determine the image of a point in the given line. Here also same. See here, plane will be given to you, and here one point alpha comma beta comma gamma, and plane equation is given to you, ax plus by plus cz plus d equal to 0. Now find the put of this alpha comma beta comma gamma on this plane. Find the put of this point. It is there on the space. Find the put of this point on this plane. Let us take that put be x1 comma y1 comma z1. Now you know that put of the perpendicular formula which you learnt in the straight lines. X here. This is the put na x1 minus alpha by x coefficient a. y1 minus beta by b. z1 minus gamma by c, which is equal to minus of a into alpha, b into beta, c into gamma plus d whole by a square plus b square plus c square. Okay students, same like put of the perpendicular formula which you learnt in the straight lines, but here z term extra will come. Apply this formula and equate these two so that you will get x1. Equate these two, you will get y1. Equate these two, you will get z1 in the simplification part. This is called put of the perpendicular theorem from plane. So in the same manner, sometimes they will ask you image also. So here, point here, plane equation is ax plus by plus cz plus d equal to 0, and in the space there is a one point alpha, beta, gamma, and find whose image. Here you will get image, same like straight lines. Let it be x1 comma y1 comma z1. Same formula, but here extra 2 will come because the distance from point 2 to the plane is equal to plane to the image. So that here you get 2. See, what is the formula? x1 minus alpha by a, y1 minus beta by b, z1 minus gamma by c, which is equal to minus 2 into a alpha, b beta, c gamma plus d by a square plus b square plus c square. Okay students, I hope you have understood what I explained in this class. So this is the complete concept of this plane, which helps you in the competitive exams like MSET, or recently they changed the name of the exam, no? Engineering, Agriculture and Pharmacy set, EAP set, and it helps you in the mains and advanced also. Thank you students.